Okay, let's continue with what we want to investigate with regards to periodic phenomena and taking a look at the tangent function. Now we said that the tangent function is going to be defined as tangent of x equals sine x over cosine of x. So if we go ahead and take a look at some of those values, we can then go ahead and determine the values for tangent of x. So I just went ahead and created a chart here. Here's x. And notice that what I did is I took all of the multiples of pi over 4. So 0 pi over 2, 2 pi over 4, which is pi over 2, etc., all the way to 2 pi. And here are all the sine and cosine values for all of those particular x values there, radian x values. And then I can go ahead then and take a look at the ratio of the sine over cosine for that particular radian value. And in this case, I come up with 0. In this case, I come up with 1. And notice that at pi over 2, you actually come up with an undefined, because at pi over 2, sine of x is equal to sine of pi over 2 is 1, and the sine of pi over 2 is 0, so 1 over 0, that is undefined. And you can go ahead and continue with that all the way through 2 pi, through 2 pi. So what happens then is I just took all of this information and transferred it to a graph. And this is what your parent tangent function looks like. Notice that one of the key points are these points here, because those are going to be restrictions on our domain. And at pi over 2 and at 3 pi over 2, we are actually going to have vertical asymptotes. Now the other points are going to be nice and easy points to graph because they're familiar to us. So 0, 1, negative 1, 0, 1, negative 1, 0, 1, etc. And so the only way that we can actually go ahead and connect all of those values together while still being honest to the vertical asymptotes is with a curve that looks like that. So let's go ahead then and take a look at some of the things that we can look at, some of the important characteristics of the parent function of tangent. Okay, so notice that there's really no principal axis, okay, as we usually defined it in regards to sine and cosine. But we can still go ahead and consider this line here the principal axis. Okay, that's going to be, say for example, the axis by which we can then go ahead and look for shifts, vertical shifts with any child function that's given. Okay, and it's just basically going to be the middle point between those two. If you average those two, that's going to be the value that you come up with. Now, notice that there are no max or min values, of course, because there's asymptotic behavior by this curve. And so we say that there are no min or max values. We know that the period is also going to be pi, because if I go from here to here, between the two vertical asymptotes, that length is going to be pi. There is no amplitude, because of course we said that there is no max or min values. And the vertical asymptotes exist when the cosine of x is equal to 0. So that's consistent because of course we said that you cannot have a denominator equaling 0. Now, if we have the general form, notice that the general form is exactly the same thing as sine and cosine. There are, of course, some slight differences. Now, in terms of the amplitude, we really don't have an amplitude, but I'm going to call it the amplitude because it's going to be the distance away from what we will call the principal axis. So here you go. This is where it is. It's 1 in this case. Okay. Now, if your child function, if a graph of a child function was given to you and it was all the way up here for that associated point, then you know then that the A, or the amplitude, is twice as large. Okay? Now, if we go ahead and take a look at the period is going to be calculated exactly the same way that we did for sine and cosine, except for the fact that we know that pi is now the period for the tangent function. Now, if we go ahead and take a look at a horizontal translation, the key is to look at, say for example, for any child function that's given, where does it actually cross the principal axis? And when it crosses, it has to, of course, go this way. Okay? And then with the vertical translation, again, it's going to be where is that principal axis. And so what we can do then is, given any particular graph of a child function that is going to represent the tangent function, we can always go ahead and use this information here to determine the actual form of that particular family member. Okay, so there you go. Tangent function, again, based upon the values of sine and cosine. Notice that there are some very important things to notice because it is different from the sine and cosine values and the sine and cosine graph, as well as the functions themselves. And notice that there are some similarities with the general form, but there are some differences because we're talking about the tangent function instead of the sine or cosine function. Okay, so we'll take a look at some of those tangent function graphs. We'll also go ahead and investigate how we can take a look at finding some of these parameters so that we can determine a particular member of the family. Okay, so we'll go ahead and see how those problems work out, and we'll talk to you next time. Okay, see you in class. Bye-bye.